Hello guys, welcome to our Learn Python and Android tutorial. I'd like to personally inform you that this is my first video. So before you leave, do ensure to hit the like, subscribe button and leave a comment below. I'd like to know what you think about my tutorial, and then hit the notification bell for when we drop a new video. Thank you. And I like to most of the videos, if you go to YouTube, you see most probably teach you all that you need to know about programming, but they are more focused on PCs, personal computers, laptops and desktop computers and the rest. But nobody seems to put pay attention to the smartphones. So that's why I took my time to make out this tutorial for you guys. So today let's go into the topic. Today we are not going to programming writing code directly. We are going into knowing the concept of programming itself. So these are going to be our topics. The first is, what is a computer program? What is an algorithm? What is programming? What is a programming language? Types of programming languages: assemblers, compilers, and interpreters. So today we'll be stopping at assemblers, compilers, and interpreters. So what is a computer program? A computer program is simply a set of instructions that tells the computer what to do, how to perform a specific task. Okay. So suppose you want the computer to compute the sum to find the sum of two numbers 20, 20, or let's say we wanted to find the sum of collect two numbers from a user and then add them together and give out the result. So we will first tell the computer, hey computer, collect this value from the user, add the values together, and then print out the results. So that's how the instructions will go. So by these instructions, when the user wants to add two numbers together, the computer will know that it is to collect the two numbers, add them, and then give the results back to the user. So that's what a computer program is. So a collection of this instruction is called an algorithm. Collection of computer programs is called an algorithm. So by definition, an algorithm is a set of well-defined procedures or steps in performing a specific task. That's why I said a collection of the instructions. That's the instructions enable the computer to perform a specific task is an algorithm. So what is programming itself? Now, so programming by definition is a process of taking an algorithm and encoding it into a notation in a programming language so that it can be executed by a computer. What this simply means is that programming is taking the algorithm, this set of instructions, and then writing it in a way that the computer will understand it. You can't say the computer doesn't understand Queen's English, it doesn't understand French, it doesn't understand uh, Latin or any language, any human language. What it understands is the computer language. That's the zeros and ones. The computer works strictly on binary code, zeros and ones. So in order to pass these instructions to a computer, we need to use a programming language. Get that? A programming language. We need it to pass instructions to a computer. So what's programming language? A programming language is simply a language designed to communicate instructions to a computer. That's to tell you that the computer does not understand Queen's English, it does not understand French, it does not understand Yoruba, it does not understand any human language. What it understands is zeros and ones. So in order to pass these instructions to a computer for it to perform a specific task, we need a programming language. It's a special language designed to communicate instructions to a computer. So what are the types of programming languages? Let's take this, we are done with that. So what are the types of programming languages? Now we have two types. We have two types of programming language. You have the low level language. The low level language has little or no abstraction or no difference from the machine language, the machine code. That's when we talk of little abstraction, we're talking of assembly language. When we talk of no abstraction, no difference, you're talking of machine language or machine code. So what are machine language? What is machine language and what is assembly language? Simply, machine language is the zeros and ones understandable by a computer. Now, the machine language consists of simply zeros and ones. This is, you see, have your normal characters, your normal strings represented by just 1 0 1 0 0 0 1 some. So the thing with machine language is that it's very, guys, as I was saying, machine language is the language directly understood by a computer. That is, it does not need any conversion, it doesn't need any compilation, it does not need any interpretation. It is directly understood by a computer. And as I said before, computer only understands zeros and ones, binary codes. So the machine language consists strictly of binary codes, and the thing with machine language is very difficult to write. Before you write a single data, could be represented by a lot of numbers, a lot of zeros and ones. You will have a represented by, we have a single letter represented by a whole lot of zeros and ones and ones and zeros. Imagine just your letter A who could be represented by 1010. So before you write B, when you talk of B, you see 1011, talk of the rest, and then before you write just a single sentence, or let's not go that far, before you write just a single word, you'll see that the whole a whole page will be full. So the thing with machine language, it's very difficult to write, and then it's dependent on the machine architecture. That's dependent on the computer architecture. This makes it very hard for portability. The language is not easy to write, it is not portable, it is it's prone to a lot of errors. That makes it very hard to maintain and debug. We get into them. Maintaining, that's keeping updating your code from time to time. Then debugging, that's checking and getting rid of errors in your code. We'll talk about that when we get into the deep into the tutorial. So that's just it with machine language. It is almost impossible for human beings to write. That's it. So nobody wants to nobody even uses it. Rare you see anybody writing machine language. Who wants to write that? How? The assembly language is, by definition, is a human readable notation of the machine language. That is the understandable version of the machine language, the human readable version of the machine language. So programmers intending to write codes in the machine language do tend to use the assembly language. And the thing with the assembly language is that it's the thing with assembly language, sorry, is that it represents the zeros and ones, the binary codes of machine language with alphanumeric symbols called mnemonics. So the since the it uses alphanumeric symbols, this makes it very easy to work, work with, and then remember, thus reducing the chances of errors and bugs. Like bugs are errors in computer, bugs are errors. And then, sorry, let's take the ones we are done with so I know what I'm doing. This reduces the chances of bugs or errors in our program. In our program, sure. So this machine language, the use of mnemonics is like an advantage over machine language. So the thing with machine assembly language is that they are machine dependent. That's they are also dependent on the computer architecture, the internal working system of the computer. So this makes it very hard to move it from one device to another without changes. So for this reason, most people nowadays don't use assembly language. It will be very difficult to still find a person still using machine or assembly language. So that brings us to, now you're done with that, we'll go to high level languages. Are more like human language and less like machine language. They are written in a form that's very, very, very close to the human understand. High level languages are more like human language and less like machine language. So they are written in like a form that is close to the human language. This makes it easy for programmers to write programs, unlike the machine language when you have to focus on coding and to focus on decoding before you writing your programs. This just enables the programmer to focus on writing the program. He doesn't have to think about going through, understanding the syntax, breaking down the syntax. He has to just focus on writing codes. That's the advantage of high level languages. So one thing about high level languages again is that they are not machine dependent. That they can be moved from one system or one platform to another without with zero with little or no changes. Move from one platform to another with little or no changes at all. So that's the thing about high level language. And the high level languages, there are different high level languages. We have There are some examples of high level language. We have our Python. That's the course we are working on here. We have Java, JavaScript, and Ruby, C, C++, C Sharp, and the rest. There are lots of them, thousands. So from there we'll go into assemblers, compilers, and interpreters. So from here we'll now round up our tutorial for today. So what are assemblers? So when we were talking of high machine language, you spoke of being the only language the computer understand, which is zeros and ones. So the assembly language is like a language close to the machine language. So high level languages require compilers and interpreters to convert their source codes as codes written in high level languages to machine language. So what are compilers, or what is a compiler? Well, a compiler is simply a system software program that transforms high level language source codes into low level machine language all at once before they are executed. This simply implies that the compiler converts source code to machine language all at the same time and then proceeds with executing the resulting machine language code. Programming languages such as C, C++, and C Sharp and Java use compilers. Well, not all programming languages use compilers. Programming languages such as Python, Ruby, and Perl, the source code is frequently executed directly using an interpreter rather than first compiling and then executing the resulting machine language. And an interpreter simply is a software that reads source code one statement at a time, translates the statement to machine language, executes the machine language statement, then continues with the next statement. This is because the interpreter must analyze each statement in the source code each time the program is executed and then perform the desired conversion. This is not necessary with compiled code or compiled code, since the code was fully analyzed during compilation. However, it can take less time to interpret source code than the total time needed to both compile and then run the code, and thus the interpreting is frequently used when developing and testing source code for new programs. So at this point we'll stop there, but before we go I would like to introduce you. So next, in our next tutorial, we'll be talking of qualities of a good program and algorithm, flowcharts, and pseudocodes. We'll talk of Python itself, where to code Python and Android, and then writing Python code. So in our next tutorial, you should be expecting these topics being broken down into details. So till then, let's call it a day.